Okay, so today we're going to look at section 1.6. It's shifting, reflecting, and stretching graphs. So the last lesson that we had was about special kinds of graphs. So we had the constant, we had the absolute value, we had the quadratic, we had the cubic, we had the step function, we have the inverse function. So each of those functions have a specific, here, let me just do this. So we have, for example, if we have the absolute value, the absolute value graph. Now this would be y equals the absolute value of x. Okay, now the absolute, y equals the absolute value of x has a vertex at 0, 0, and then it comes off of there at a 45-degree angle. Okay, so when we talk about shifting, reflecting, and stretching these graphs, then what we're doing is we're taking this basic absolute value graph and we're doing something to it that we can still see what it should look like. For example, we're going to do a vertical or a horizontal shift. So if I were to do a vertical shift with this thing, I would take, okay, so let's do it in a different color. So let's say we have y equals the absolute value of x plus 2. Now, since the plus 2 is outside the function or the operation there, so it's outside the absolute value operation, then this is a vertical shift. So what we would do is we would take this graph, we would move it up 2 places. So I move my vertex up 2 places and I still have a 45-degree angle. So it's just the same graph, just shifted up 2 units. If I had a horizontal shift, then that would look like this. And now you see that it's inside the absolute value function or operation. That is going to be a horizontal shift. And the plus 2 went up 2. The plus 2 here is going to go left 2. So it's going to go in the opposite direction. So we're going to move our vertex 2 units to the left. And now we have our 45-degree angle from there. Okay, so that is a shift. A reflection is where we're going to reflect that over the x-axis or the y-axis. In this particular case, if it was a shift over the y-axis, it would give us the exact same graph. If it's a shift over the x-axis, then we would be looking at a graph that looks like this. And we'll get to that, what that looks like later. And then the last thing is a stretch. A stretch is going to change the steepness of our absolute value. So if I have a 1/2, y equals 1/2 absolute value of x, then that's going to give me a less steep of a v. And if it was y equals 2 absolute value of x, then that means it would be a steeper v. Okay, so basically those are the 3 types of things that we're going to be talking about today. I personally think the shifting of graphs is the easiest to get used to. Okay, so if you look again, here we have another example. This time it's the quadratic y equals x squared is our base. So let's just go ahead and follow that. So here's our base equation, that parabola, where the vertex is at 0, 0. And then you'll see here that we have an inside the square, so that would be a horizontal shift. And it's a -2, so that means it goes to the right 2. If it was a +2, it would go to the left 2. All right, and then here you have your base. Your base is y equals x squared, so that's right here. But this time you see that that plus 2 is on the outside of the square. That is a vertical shift. And it's plus 2 and it went up 2, so it goes in the same direction. Okay, and here's a list of all of that. If you're not, if you want to write it down, you got the vertical. Here, I'll make that bigger. You have the vertical shift, that's C units upward, looks like that. You have the vertical shift C units downward, looks like that. Then you have the horizontal shift to the right and the horizontal shift to the left. Okay, so let's get to an actual example. So we have the graph of f of x equals x to the third. We're going to do some shifting with it. Okay, so first of all, let's go ahead and graph the generic y equals x to the third. Okay, so now y equals x to the third. As you know from the last lesson, lesson 1.5, looks like this, with this as a critical point right there at 0, 0. Okay, so now I want to graph that same graph, only I have a shift, and that minus 1 is on the outside. Oops. It is on the outside of the cube, so that means it's vertical. So I'm going to go down 1 unit. So I'm going to take this and move it down 1 unit, and then I've got the exact same graph, only it's shifted down 1 instead. Okay, so then we look at the next one, and this time, whoops, that's not a very different colored. Let's try this. This time we have 2 different things going on. We have this is inside, so that's a horizontal, and it goes in the opposite direction, so this would be left 2 units, and then this is outside, so that's vertical, so that is going to go up 1 unit. So we start at 0, 0, we move 2 units to the left and 1 unit up, and now we have that same general shape, only it's shifted 2 units to the left and 1 unit up. Okay, and you can do this with any of those special functions that we had from the previous lesson 1.5. Okay, so let's talk about reflections. We have 2 different kinds of reflections. One is the reflection over the x-axis, and the other one is the reflection in the y-axis, okay? And you'll notice the difference here. We have the x-axis has a negative outside the whole function, and the y-axis has a negative on the inside of the function. So let's take a look at those examples. So we have the graph of the function f of x equals x to the fourth. So the generic picture of that would be right here. So that's what the normal x to the fourth looks like. Okay, and then we have, oh, this isn't, okay, so we have this, we're supposed to find the equation that corresponds with each of these. So it has, we know it's some kind of x to the fourth. So we know f, let's call it g of x. So we have g of x equals, but something happened to this x to the fourth. There is a vertical shift and it went up 2 units. So that is outside of our function. Okay. So, sorry, there was a pause there, but I just wanted to double check to make sure I'm telling you everything correctly. So, when you have that flipped over version right here, then that would be a negative out front of that x to the fourth. Okay, so this right here is the equation for that graph. And then for this equation right here, we're going to start the same way. So we have, let's do h of x. So we have h of x is equal to, now this time there is a horizontal movement. So the vertex is 3 units to the right. So this would be x minus 3 to the fourth power with that negative out front. That negative flips it down so it goes like this. So this would be the equation for that. Okay, so that is how we do a horizontal flip. Okay, so let's talk about some more reflections and shifts. So we have this example 3 right here. We need to compare the graph of each of these with the general graph of f of x equals the square root of x. So let's graph that first. So that looks like this. So it's like half a parabola going to the right, and its vertex is at 0, 0. Okay. We have this one right here that has a negative out front of that square root. So that is going to be a flip over the x-axis. So everything is the same, only we flip it across this so that my graph looks like that. All right, then we go to this next one, and you'll notice that this time the negative is on the inside of the function or the operation, the square root operation. That means it is a y-axis. The y-axis flips. So that means instead of going down below the x-axis, we're going to flip it over the y-axis. So it looks like this. All right, and then the last one, let's see what color. The last one is going to be a horizontal. It's a horizontal shift. So we're going to go 2 units to the left. And then it's got the negative on the outside. The outside would be an x-axis flip. So we're going to take our original pink graph. We're going to move it 2 units to the right. And so it would normally look like this, but we're going to flip it down. So it looks like that. Okay, so that's how we reflect and we shift. All right, so now we're going to come to non-rigid transformations, and this is where we are either going to stretch it or shrink it. And I have trouble with their wording, and I can't remember which one's the vertical shift and shrink, and which one's the vertical stretch. All I know is that when you have a coefficient in front of this that is larger than 1, it's going to make it narrower, or the slope is going to be steeper. So if you look at this right here, that's your graph.